Hello everyone, welcome to GAE channel. This is Amy. I'm an engineering manager and have been in this field for over 15 years. Our videos cover all essential aspects of electrical design. Most of the content are referring to a recent published book, Practical Power Plant Engineering. This book is a result of 50 years of practical experience from working in different industries and by associating with many experienced engineers. The author of the book, Zach Batlev, is a very intelligent, knowledgeable, and experienced electrical engineer. Without further ado, let's have a look at the different types of power plants. The types of power plants are classified depending on the type of fuel used. For the purpose of bulk power generation, thermal, nuclear, and hydropower are the most efficient. In most cases, the renewable resources are located away from the load, and the power produced transported to load centers by long transmission lines. On the other hand, the generating plants using fuel and built closer to the load centers, and the fuel resources are transported to the plants. Let's find out in detail how these power stations work. First, let's have a look at hydroelectric power plants. Hydroelectric power plants are one of the most effective and eco-friendly of all power plants. In a hydroelectric power plant, electricity is generated from water. In detail, the potential energy of water is converted to electrical energy. When water is made to fall from a height on the turbine, it spins the armature, which is connected to a generator. When the turbine spins, the generator starts to produce electricity. The electricity is then routed to all the different substations to distribute the power. The hydropower is dependent on the product of water head and water flow. This is a formula to calculate the power, where P is a power measured in kilowatts, W is a specific weight of power, 9.81 is a gravitational constant, H is a height of fall in meters, eta is the overall efficiency of operation. It is a product of all of the component efficiencies, which are normally the turbine, drive system, and generator. The advantages of hydropower plants are, it is clean energy with low production cost. The resource is adaptable to changing demand. It can be used as a base or peaking power, and a quick start within 1 minute. Also, it can be designed as a synchronized condenser to provide MVRs, relatively simple operation and maintenance, and a high efficiency, usually at 80 to 85%. The disadvantages of hydropower plants are, it needs large capital cost for civil works. It has relatively low capacity factor, ranging from 15 to 50%, and the water inflow are not predictable. Now let's talk about thermal power plants. A thermal power station converts heat energy into electricity. Typically, water is heated into steam, which is used to drive an electrical generator. After it passes through the turbine, the steam is condensed into a steam condenser and recycled to where it was heated. The greatest variation in the design of thermal power stations is because of the different heat sources, including coal, natural gas, waste, or petroleum. Thermal power plants are designed on a large scale for continuous operations and base loading. The majority of plants use 1 or 2 400 to 600 volt megawatts units. The advantages of thermal power plants include baseload operation, low capital cost per kilowatt hour, high capacity factor ranging from 60% to 70%. The disadvantages include pollution, slow startup time, and high standby operational losses from year to year. Now let's talk about gas turbine plant. Gas turbine plant uses a combustion engine that converts gaseous or liquid fuels to mechanical energy. The gas turbine engine compresses air and mixes it with fuel that is then burned at high temperatures, creating a hot gas to make the turbine blade spin and turn a generator as it exhausts gas into atmosphere. The burning energy is converted into electricity. The efficiency is usually less than 30%. The gas turbine plants are built with multiple units of 10 to 250 megawatts each, with a possibility of adding combined cycle thermal generation on every pair of turbine units by using the exhaust gas temperature reaching 540 Celsius degrees C. The advantages of gas turbine plants include low capital cost, quick plant construction, waste heat recovery possibility, quick engine start of peaking duty, and suitable for small remote communities. The disadvantages include high fuel cost and environmental emissions issues. Now let's talk about nuclear power plants. A nuclear power plant works by converting nuclear energy into electricity. The heat from the nuclear reactor is used to convert water into steam. The pressurized steam is then used to burn turbines connected to a generator. As opposed to coal or natural gas power plants, a nuclear power plant doesn't have to burn anything to create heat. The whole process is powered by nuclear fission. Low-enriched uranium pellets are loaded into nuclear power plant. Then the uranium atom is split, creating nuclear fission. This process releases huge amounts of energy. The advantages of a nuclear power plant are that they do not need to burn anything to create energy, so there's no pollution. The production cost is low. The disadvantages of nuclear power plant are long planning and regulation process, high construction cost, radioactivity, fuel and core containment requirements, etc. Now let's talk about diesel engine plant. Diesel engine plants are usually built for remote communities and ships. The plants usually operate as baseload generation, 24 hours a day to supply power to industrial facilities, the camp, or villages. The engines for baseload are of slow speed 400 to 900 RPM type, operated on continuous duty. These plants use liquid or gaseous fuel, mixed with atmospheric air as a working medium. During the suction stroke, the fuel is compressed and ignited inside the cylinders. The thermal energy is converted into mechanical energy to move the pistons and spin electric generator. The advantage of diesel engine plants include low capital cost, quick installation, high efficiency, waste heat recovery, quick start, suitable for small remote communities, and suitable for peaking duty. The disadvantages include high fuel cost and environmental emissions issues, and high noise, of course. Wind farm. In recent years, wind energy has become one of the most economic renewable energy technologies. Wind power is a conversion of wind energy into electricity or mechanical energy using wind turbines. The power in the wind is extracted by allowing it to blow past moving blades that exert torque on a rotor. The amount of power transferred is dependent on the rotor size and the wind speed. Wind turbines range from small 400-watt generators for residential use to several megawatt machines for wind farms and offshore. Since wind speed is not constant, the annual energy production of a wind converter is dependent on the capacity factor. A well-sited wind generator will have a capacity factor about 35%. This compares to a typical capacity factor of 90% for nuclear plants and 30% for thermal plants. As a general rule, wind generators are practical where the average wind speed is 4.5 meters per second or greater. The advantage of wind farm includes low-cost energy production. The disadvantages include high capital cost per kilowatt hour, not possible to store the energy comparing to hydropower, requirements of large site, non-predictable power production and wind turbulence issues, remote from load centers, and low capacity factor, etc. The last type we are going to introduce today is a solar energy plant. Solar energy is energy from the sun. There are two types of solar energy, solar thermal and solar PV. Solar thermal energy uses sunlight to produce heat or hot water. Solar thermal can take two forms: flat plate collectors or tube collectors. Solar photovoltaic, we also call it PV, converts sunlight into electricity. Large number of PV panels are laid out on flat ground and directed toward the sun. The plates generate DC power after absorbing sun rays. Then the DC power is converted into AC power through power inverters. The advantages of solar PV are low cost production and easy to maintain. The disadvantages are high capital cost per kilowatt hour, large area required, usually remote from load centers, low capacity factor, operates limitation only during the day hours, large output losses, generate no reactive power, and sometimes wind issues even.